question 6 on the fall 2013 final exam. Okay, so the question asks to write a method that takes an arbitrary array of integers as input and create a new array with the same values in reverse order, and to call the method reverse. Okay, so obviously this question focuses on the topic of arrays, particularly the manipulation of arrays to get a desired result. The question asks to take an already established array as an input and manipulate it such that the outcome is the inverse of the original array in one method. So, as you can see in the question, it says we have to take an arbitrary array, right? I established that array as just array, and that array could be of any length, and it could have any values, any int values, of course. It could be 1, 2, 3, 4, 5, it could be 5, 12, 27, 16, whatever, it doesn't matter. So obviously, since we're finding the reverse array, it's going to be the same length as the original, so I said that the length of the reverse array is the same length as the array. Okay, so that was, I would say, the easy part of this problem. The hard part is the actual defining of the values within the reverse matrix, as the first term of the reverse matrix is the last term of the original, second term of the reverse is the second to last term of the original, etc. So yeah, using a for statement, you can do this quite easily actually, just using some logic. So I establish just a variable as 0, and as long as it's less than the length of the original array, which let's say it is 10 in this case, just an example, and j is incremented so that it increases by 1 every time it completes the loop, then the value at that value j, so in the first loop it would be 0, so the value in the 0th term, which is the first term in the array reverse, would be equal to the array length minus 1, so that would be 10 minus 1, so 9 minus 0. So that says that the reverse value of the first point in the matrix is equal to the last value, so array 9 in the array matrix. So a common misconception that some people may have with this program is defining this part wrong, the array length minus 1 minus j. So I remember the first time I did this problem, I actually didn't have the minus 1, and I got a runtime error. And that was because in the first case when you do this, let me just take it out so you can visualize it better. Reverse of 0, which is the first term in the reverse matrix, would be equal to the length of the original array, which we said was 10, minus j, which is 0. So it would be the 0th term, so the first point in the reverse matrix would be equal to the array 10, which is technically the 11th term because we started 0, right? So you'd have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as the 10 terms in your array. And that term doesn't exist, so that does compile, but you would get a runtime error from that problem. Okay, so if you're still not grasping it, the reason you do array length minus 1 minus j is so you avoid that runtime error. And I laid out here what your results would be of the arrays if you were to do it the appropriate way here. So I laid out every case, but I skipped a few obviously because it's repetitive and I'm sure you can see it. So as I said before, the first time you go through the loop, j will be 0, so you're going to have reverse of 0, so that's the first term of the reverse array, equals, doing this arithmetic out, you get 9, so that would be array 9, which is the 10th term in the array. So the first term in the reverse array is the 10th term in the original array, which is exactly what we want. And that repeats on for the other 9 terms, so the second term in the reverse array is the 9th term in the first array. And that goes on until the end, so that the last term in the reverse array is the first term in the original array. Okay, so to help you understand this a little better, I put this logic and that problem in a full Java program that you can compile. So let's go through it. So you have to do a import a Java scanner because I'm going to be scanning 10 integers into here, excuse me, and then we'll be doing what we did in what I showed you before, which is in this method. So we'll get to that in a little bit. So first, everything's in the public class extra credit, okay. In the main method, this is where we establish the 10 integers in the original array. So obviously I have a scanner, I initialize the scanner, and I prompt the user to enter 10 integers. We're just going to assume here that they enter integers and nothing else, because this problem focuses on arrays and not scanners. So first we have to initialize the array to have 10 values in it, right? Because we're going to be typing in 10 integers, so we want it to have a length of 10. So in order to make this simple and not really long, I made a for statement which says that it's going to loop through 10 times, and each time it's going to ask the user to enter a integer. So when they do, after this for loop finishes, we will have 10 integers, and that will define the array. And then afterwards I do just a little line for neatness, and then we call the method, which is pretty much the problem that I just showed you. So that is quite literally the same thing. So it's right here, this whole array, and that gets the reverse array, from the original array. And then I print it out nice and neat with the original and the reversed, and I can show you that it works. So sorry. Oh. This should compile well without errors. Okay, so we're going to type in 10 integers. For the sake of simplicity, I'll make it 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there you go. The original is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the reversed is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Easy. Okay, so I hope you have a firm understanding of what we did up to now with reversing an array. So now I'm going to do a little bit different of a problem with pretty much the same concept. Rather than reversing an already established array, we're going to invert an already established array. So if we had values of 1, 2, 3, 4, and 5, the inverse array would be 1 over 1, 1 over 2, 1 over 3, 1 over 4, and 1 over 5. Not very different than the original, but it's good practice nonetheless. So everything is the same with defining your original 10 integers, obviously. The only difference comes in the actual method call of inverse. So you do a loop again from 0 to the length of the array, which is 10 in this case. But rather than do that algebra that we had before in the right here, the array length minus 1 minus j, you don't have to do anything within the brackets. It's all outside of the brackets. So basically the inverse of a certain value, so let's just say 0, so the inverse in the first term is equal to the 1 over the value of the original array. So if your original array was at 0 at the first term was 1, then your inverse array would be 1 over 1. And if I had 2 as the original array at the first term, then inverse of the first term would be 1 over 2. So not really any different, but I'll show you how it comes out nevertheless. Okay. Okay, so once again, I'm going to do, actually I'm going to make it different this time. I'm going to make it 2, 2, 2, 2, 2, 2, 2, 2, and then 4. Not 4. Okay. Oh, one thing I did forget to mention. In order for the inverse to work, obviously you can't have integers because if you had integers, then they would all round down to 0 and you wouldn't get an appropriate answer. So I actually made every single value in every array, in the original array and in the inverse array, a double. So although you enter an integer, it will recognize as a double, and there you can see that it recognizes 2.0, because then when you do 1 over 2, you get 0.5 and not 0, because that would be the case if you left it as an integer. That's important to know. Okay, so that's about it for this problem. My name's Tony Nickolov, and this is CSE2.